To learn how to solve radical equations today. A radical equation is just an equation that contains a variable in the radicand. So it's not that just it has a radicand that's in an equation that has a radicand, but the variable actually must be inside the radicand in order for it to be classified as a radical equation. So let's look at this first example. We have the square root of x equals 10. So to undo a square root, we are going to square both sides. So the square undoes the square root, giving us x. And then 10 squared is 100. So that means x equals 100. And then we need to look and make sure that it checks in the original equation. So if I were to substitute 100 for x in my original equation, I would have the square root of 100. And the square root of 100 equals 10, which means that it does check out. So after both sides of an equation are squared, any resulting solutions must be checked in the original equation. Check them, and after you check them and the solution does not make the original equation true, we call that solution invalid, and it's called an extraneous solution. Notice the word extra there. Extraneous solutions. An invalid, it does not make a true statement when it's plugged into the original equation. So here are your steps for solving radical equations. First, you're going to isolate the radical on one side of the equation. So get the radical out all by itself. Then square both sides of the equation. Then we're going to square both sides. And then on the left side, the square undoes the square root, giving us x minus 3. And then negative 4 squared is 16. And then from there, we'll add 3 to both sides, and we get x equals 19. All right, so now we have to check. We have to make sure that if I substitute 19 for x into my original equation, do I get a correct answer? That your solution is going to be extraneous. Example, our radical is already isolated, so we can go ahead and square both sides. So on the left, the square undoes the square root, giving us 2x plus 5. And then 8 squared is 64. We subtract 5 from both sides, and then divide both sides by 2. We get 59 over 2. So if I were to plug 59 over 2 back into my original equation, the 2's would cancel, leaving me at 59. And 59 plus 5 is 64. And the square root of 64 is 8, which is what my original equation had. So that means that it checks out, and x equals 59 over 2 is the correct answer. Next example. We have 10 minus 2 square roots of x equals 0. So remember, I have to isolate the radical first. So I'm going to subtract 10 from both sides, and then I'll divide both sides by negative 2. So now I have the square root of x equals 5. So then I will square both sides, and then on the left side, the square undoes the square root, leaving me x. And then 5 squared equals 25. So I get the solution x equals 25. Now I just have to check it. So if I replace x with this 25, the square root of 25 is 5, and 2 times 5 is 10, and 10 minus 10 is 0, which is what my original equation had, which means that it does check.